This study is significant because it turns the harmful water hyacinth into charcoal, helping both the environment and the economy. It also creates a low-cost filter that reduces air pollution and health risk. The findings can inspire industries and students to develop more eco-friendly innovations.
In the Philippines, air pollution continues to be a rampant issue that negatively affects our health. But what exactly is air pollution? Air pollution is the emission of pollutants such as VOCs and gas emissions that build up in the atmosphere. These gases in large emissions can be very deadly. It is caused by vehicles, factories, and even appliances that we use every day. In addition, air pollution results to global warming, which only further encourages the use of air cons that contribute more to the problem. Attempts to negate these effects include the use of air purifying filters such as HEPA. However, these filters are very costly and need replacements that are often non-biodegradable, which ultimately leads us to our proposed product, which is the Hydrochar Airblock.
With all those was said and mentioned, the main purpose of Water Hyacinth Hydrochar Airblock is to test Water Hyacinth charcoal's capability in air purification and air filtration. This also allows us to explore and expand knowledge about Water Hyacinth charcoal's application in terms of applying it in solving environmental problems.
For the objectives of the study, the first is what is the amount of the VOC left after 2 hours? Number 2, how does the environment impact the chemicals in the study? And lastly, is there a significant difference between the use of water hyacinth-derived charcoal and HEPA filters?
Now let's discuss about our methodology. So for our study's research design, we followed this experimental research design, which involves manipulating independent variables and seeing their effects on dependent variables.
Moving on to the process flowchart, the study begins with preparing the materials and collecting water hyacinth from Marikina River. After plant identification, the water hyacinths are dried and treated with phosphoric acid to create charcoal. A wooden prototype frame is built and tested at the air testing facilities. The data is collected and analyzed, and all wastes are properly disposed of.
Before we head on to results and discussion, let's discuss about what we did for our testing. These are our setups, and these setups have the same amount and types of contaminants, which are all sources of VOC gases. And for our sensor, we use the alcohol and VOC gas sensor from Adafruit.
With the help of our testing setup, the researchers did 8 trials of 15-minute tests with each type of filter and the non-filtered, and also recreated the setup with low walls to gather the data of the open area. To determine the difference with the results of the non-filtered and the 2 different filters, the researchers used one-way ANOVA to compare the results of the 8 tests made with 3 different groups. To also determine if the testing area had an effect to the circulation of the gas, the researchers used t-test to compare the results of the non-filtered tests and the open area test, which helped the researchers determine the difference. After the data was gathered, the researchers first proceeded with the ANOVA test with 3 different samples, wherein the data group were no filter group, HEPA filter group, and the biochar group. The results of the p-value was 0. There were no difference between the results of all samples. To further determine the exact difference between all samples, the researchers used post-hoc tests, which showed little to no difference in the results. After the one-way ANOVA test and post-hoc test, the researchers used t-test to determine the difference between the controlled environment or testing area and an open area, which the result 0.02066666, which if interpreted means that it showed 0.0665, wherein if p-value is greater than 0.05, in 2 tailed tests, the results would be concluded as in no significant difference, so the researchers can conclude that the testing environment does not affect the gas circulation.
We also solved for the filtration performance and clean air delivery rate of both filters, which gave us the result that there is a 1% difference in their filtration performance, and for the clean air delivery rate, it shows that there is a slight increase on the amount for a Hydrochar Airblock. Therefore, this concludes the Hydrochar Airblock is an effective solution and shows potential as an alternative to commercial filters or commercial carbon filters.
And lastly, these are our references or bibliography used in the study.